Hello engineers, how are you all? So welcome to the 12th lecture of ASME BPVC Section-VIII Division-1 training, that is basics of division design stresses. So today we will discuss about some basics of design stress and what are the types of stresses according to ASME Section-VIII Division-1 and Division-2 also. So let's get into the topic, guys. So what is stress, guys? What is stress? So we know that if you apply a load on any wall, there is some internal resisting force happens to resist our external load. So stress is the internal resisting force with respect to area acting on a body is nothing but a stress. It is the internal resistive force with respect to external loading is nothing but a stress, guys. The units of stress is Newton per meter square. So generally we internal resistive force by area is nothing but the stress formula. And next one is strain. So if we apply a load on any bar or any component, there is a change in some changes in that particular component, change in length, change in diameters. So depending upon the load, okay. So strain is the change in length to the original length is nothing but the strain, guys. So strain has no units. So delta L is the total elongation and L naught is the original length. Okay, this is all about stress and strain. And next one is types of stresses. We generally know there is a tensile stress and compressive stress. There is a shearing stress, torsion, bending stresses. These are the all types of general stresses we already know. I am not going to detail. I hope you already know these basics. Okay, so next one is Young's modulus. So what is modulus and how to find this Young's modulus from experiments. So Young's modulus means stress by strain. In college days, we generally know Young's modulus means stress by strain. In our college days, we did one test like UTM test. That means tensile test. By using this tensile test only, we will find the Young's modulus, guys. So let's take example. That is tensile test. So in tensile test, we took a workpiece and stresses to along its length, guys, in one direction only, in uniaxial direction. So this is uniaxial direction. You are showing here arrow mark sides. So we are stretches the workpiece, whatever the workpiece is there, we are stretching that workpiece in a uniaxial direction. That is by applying the load in opposite directions. And next, so during this test mission measures the applied load. So how much load we are applying on this workpiece that will observed by this test mission. So the main output from the test is stress strain curve, guys. Here I already showing that stress strain curve, which shows the material deformation at different levels. So firstly, if we applied a load, we will observe some slope. This is the elastic region. So up to this region, our material will regain its original shape. And after the sealing will occur, so in this yielding, we will observe some deformation and after that it will reach us to tensile strength, ultimate tensile strength. This is the maximum stress of our material with and without failure. Okay, and after this if we increase the loading, our material will fail, our material will fracture. Okay, this is all about stress strain diagram, and there is a one elastic region is there and plastic region is there. Up to elastic region, our material will regain its shape. So now Young's modulus is the gradient of the slope of this elastic region. So up to this region, what is the gradient of this slope is nothing but our Young's modulus. So generally from Hooke's law, the modulus of elasticity is the gradient of slope in this elastic region. So what Young's modulus generally gives. So what it is telling to us? So generally Young's modulus gives how much stiff is our selected material. So generally it is the measure of how stiff a material is. So if he is higher, I mean Young's modulus is higher, material is also high stiffness. So this is important material property, guys. So while choosing the material for our design of pressure vessel, we need to consider this Young's modulus or modulus of material. So not only in pressure vessel, guys, there are so many industries, automobile industries also will consider this Young's modulus before selecting the material. So I hope you understand this basic information. Before going to the next point, this is a mechanical training world YouTube channel. Here you will get all the training related videos that is about the two mechanical training related videos. So if you are new to my channel, please subscribe my channel, guys, and click on the bell icon. If I upload any new further videos, you will get a notification. If you like my content, please share to your friends also, so they will also get benefited. So next one is types of stresses, guys, or classification of stresses. So according to ASME BPVC Section-VIII Division-1 and Division-2, I classified stresses into three categories. So that is primary stress, secondary stress, and peak stress. In this primary stress also, primary membrane stress, primary bending stress, primary local stress is there, and in secondary stress also, secondary membrane stress, secondary bending stress is there. So we will discuss some more detail, guys. Generally, what is primary stress? This primary stress will generate due to mechanical loadings, guys. So general mechanical loadings is there, right? That is self weight of the vessel, pressure. Generally, these primary stresses caused due to mechanical loadings like pressure, empty weight, nozzle loadings. Okay, so it will not occur at discontinuities like discontinuities. It is away from discontinuities. So here you are showing that this is not located at discontinuities area. Discontinuity means welding areas. So this is not present at welding areas. So it is caused mainly due to only mechanical loadings. So that is general loadings. So that is not nothing but primary stress. So all circumferential, longitudinal, radial stresses are generally we consider as a primary stresses, guys. Okay. Stresses exceed the yield strength will result failure or distortion. So if our stress exceed the yield strength of our material, so that will cause a failure, guys. So we need to take care of that primary stresses. Next one is primary bending stress. Generally, bending stresses occur due to loadings, mechanical loadings only, but these loadings will act some distance from the center of gravity. This is produced due to primary membrane loads only. So if we consider this is the head, conical head. So at the center of the head, we will generally observe bending stresses because due to there is a loads like support loads, lifting leg loads, and the nozzle loads will act at some distance from the center of gravity. Due to load acting from distance from the center of the gravity, we will face this primary bending stresses. So these are not present at discontinuities and stress concentration areas. So stress concentration area means holes, notches like that. Okay. And next, so according to ASME Section-VIII Division-1, so primary bending stresses induced in specific areas of the vessel, such as descents, center of the descent, flat head, shallow conical heads, and ligament of the closed spaced openings. So these are the general areas we will observe primary bending stresses. And next one is primary local stresses. So above two stresses are away from discontinuities, guys. But these primary local stresses will occur at discontinuities areas. Okay. Here you show here I saw shown the picture like this is our discontinuities area. Here welding is happen and at edges. So we will generally observe in these locations primary local stresses. So these primary local stresses generated due to mechanical loads. In small localized areas of discontinuities in the vessel, such as knuckle areas. Like here I already shown knuckle areas, openings, junction between shell and descent. These are the junction between shell and descents and telltale holes. So telltale holes are generally used for whether the corrosion is there or not. For checking corrosion is there or not, we will use telltale holes. And telltale holes also local stresses will produce. And the division 1 given some statements like the region of stress is said to be local if equivalent stress is greater than 1.1 times of the stress and distance of that region is less than root RT, then only we can said that region of stress is local stress. I hope now you understand primary stresses. There are the three types of primary stresses, and next we go to secondary stresses, guys. So these secondary stresses are generally caused due to temperature, that is thermal loads. So these secondary causes induced due to thermal loads only. And these secondary stresses have a beautiful character like self-limiting character and occurs at structural discontinuities. So for example, I take a component which is not restricted or free to expand. If I increase the thermal load, it try to expand. So by expanding, it's relieving its stresses. Okay, here no the secondary stresses will generate. But if we place a supports to restrict this component and increase the thermal loads, so there is no possibility to expand, guys, here. So it just bend like this to relieve its internal stresses. By bending like this, it releasing its internal stresses produced. So this is self-limiting characteristics. So by self-limiting, it is releasing is somewhat secondary stresses. So this is all about secondary stresses, guys. So primary stresses is due to mainly mechanical loads and secondary stresses is mainly due to temperature or thermal loads. And next one is peak stress, guys. So this peak stresses we generally observed at stress concentration areas like holes, nozzles, notches, At these areas, we will face high type of stresses. Generally, this peak stresses is the highest stress at which high localized areas and stress concentration areas. This peak stresses does not generate any noticeable distortion, but fatigue cracks may be produced. It will not create permanent deformation, but there will be some crack-like deformations are there. So, which is repairable. And we require to calculate these peak stresses only for vessels in cyclic loadings, not for other loadings. So this is the clearly mentioned in Division 1 code, guys. If you see in mandatory appendix 3, so all these definitions for stresses you will get from there. Okay. And local stresses concentration near a notch. Where you observe peak stresses means notches, some fillet radius near a hole, and incomplete penetration wells. So all these areas you will observe these peak stresses. I hope you understand the type of stresses. You mainly need to remember that primary stresses are due to mechanical loads, secondary stresses are due to thermal loads, and peak stresses are generally due to high localized areas and stress concentration areas. Okay, that is notches and holes. I hope you understand this session. Uh, Please subscribe my channel and share to our friends if you like my content. So thank you guys.